So basically, what machine learning do for you is it creates a mathematical model for any input and given output. So it tries to find a relation between input and output set of data. So now what is the set? So set can be this mathematical input like number, integers, or regression type inputs. So it tries to find a relationship. What it basically does for you is find a mathematical function that takes domain x and output result y. So it's kind of function fx that results y. So this is what a machine learning do for you. Now, if you have heard about neurons, like neurons, how it work, uh, our brain is also made up of billion of neurons, right? So the environment, process it, and then produces some output. This is exactly what how the real neuron and the artificial neuron works. For like in machine learning, we have this almost the same model of neuron, and there's a neuron. It takes some input x. Input consists of uh, several signals that is coming from different devices or different environmental factors. So it can have n number of inputs, and then it formulates, or it operates some mathematical functions over those input and produces some or output y. So basically, neuron is an input and m output terminal device, and this neuron has a capability of learning. So once this neuron has a capability of learning, it can generalize functions, and if it can generalize functions, then obviously it can do things which basically, if it can generalize function, you can say that this neuron has a learning capabilities. So now how a neuron learns something, and that is where the machine learning comes. So uh, you know that neuron takes n input and produces m output. So if we talk about really simple neuron, so what it does is it takes n input multiplied with some weights, and like each neuron signal is multiplied with some specific weight, and then some add them all and produces some y. So let's see how the real neuron, like which is present in our brain, actually works. If you know the perceptrons, so this is the image of real neuron that is present in our brain or any organism's brain cell. So this is building block of brain cell. So this is how the real neuron works. But when we talk about the artificial neurons, so actually we can't have lots of complexities there, because you know that machine learning is already very computation expensive. So we try to develop our approximate neuron model. And the basic model of neuron says that it takes some input. Say it has three inputs: x1, x2, x3. Okay, each input is multiplied with some given weight w1, w2, w3. So and then added up. So x1 w1 plus x2 w2 plus x3 w3. It gets added up. So this is your weighted sum of all the input signals. Then this weighted sum is actually act as a firing parameter that neurons should fire or not. So we have a function that is activation function. Activation function decides whether the neuron should fire, right? Whether the neuron should fire or not. So it takes this value x1 w1 plus x2 w2 x3 w3, and then it converts this value into 0 1 function that either the neuron should fire or not to fire. So there are various types of activation function. For example, one of the really basic function is logistic function. Then we have sigmoid function, tanh function. This is your tanh function. So it takes the input. You can see that it has a domain over all real numbers and range over -1 to 1. So it takes that weighted sum and produces an output between -1 to 1. And this -1 to 1 value then go to the second input to the second neuron, and so on. So now how this is how the neuron gives you output. So this is actually called feed forward mechanism. It takes the input and produces the output. So you just see that how the neuron produces output, but it is not learning anything right now.
Thank you for watching our video on machine learning. For more videos and tutorial, like, share and subscribe. And don't forget to press the bell icon so you don't miss any cool videos.